Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. This is the chapter Matter in Our Surroundings, that is class 9, and it is part 4 where I am going to explain different terms just like evaporation, sublimation and etc. Actually, in part 3, I have explained what is the effect of temperature and pressure on the states of matter. Now you know, when you apply heat to the state of matters, let us say solid, on heating it changes to liquid and liquid changes to gas. It is a common process. All you know, when solid on heating it gives liquid, liquid on heating gives gas. But there are some phenomena. But there are some process where here without undergoing to liquid it changes to gas. Solid changes to gas. So see, in some cases solid on heating changes to gas and gas it changes to solid. Then what happens here? Here without changing solid to liquid state, the solid directly changes to gas by applying heat. Solid on heating changes to gas, and what is that process? That is called sublimation. You can say activity. Now in activity, put camphor or ammonium chloride. Ammonium chloride is available in laboratory. Put in a china dish, that is a pot, and cover it with an inverted funnel. And funnel we should be inverted, you keep on the china dish. You can see the diagram here also. And the stem that is closed by cotton plug. That means here the stem cover, the stem hole where we put cotton plug to cover it and heat the china dish slowly. And what happens after that? See, this is the diagram where A is the china dish with camphor and B is the solid camphor. After some time you will observe on the side of the funnel, C is the burner for heating where flame will come and helping for heat, and D is the tripod stand and E is the funnel. Again see, china dish you put camphor and solid camphor on the side of the funnel, that is B. Burner for C, the burner for heating, and D the tripod stand, you keep the china dish properly, and E the funnel where sublimation, and after sublimation on the side it is covered. Sublimation mean what? Then conclusion, a change of state directly from solid to gas without changing into liquid state. It will not change to liquid state. Without changing to liquid state, it changes to gas. Direct change of gas to solid without changing into liquid, that is called deposition. Now you see, solid changes to gas without changing to liquid, and gas without changing to liquid it changes to solid, that is called deposition. That means on the funnel side what is there, that is called deposition. Then affect a change of pressure. Then what happens? You read already in part 3. Again we will discuss how it is affecting to the sublimation and other case. Main difference that states of matter, solid, liquid, gas. What is the constant particles, the behavior, the nature of the particles, how it is there. Main important part is all are arising due to distance between the constant particles. In solid what happened? In solid, A is a particle-let, A is a particle, all particles are known as A. In solid what happened? A, that the small distance between them. In liquid what happened? The particle A, there is a large distance when compared to solid. In gas what happened? There is a very large distance when compared to liquid and solid. What is conclusion? Solid, there is a little difference in the constant particles and distance very less. Liquid distance is more and gas distance is much more. By putting pressure, then what happened here? Observe. When you put pressure and one can press a gas enclosed in a cylinder. Why? Because there is a large distance between one particle and other particle. That is why one can compress a gas enclosed in a cylinder. Example, you know, LPG, liquefied petroleum gas, CNG, and here compressed natural gas. Here, by increasing or decreasing pressure, what happens? One can change state of matter. If a gas you put pressure more and more, it changes to liquid. Then you can observe that a natural case in our life. By applying pressure, reducing temperature, one can liquefy the gas. See, apply pressure, pressure is given more and more. Temperature less and less, then what happens? One can liquefy gas. Similarly, example say solid carbon dioxide, you have seen, you have not seen, I think you may observe, you listen, solid carbon dioxide is stored under high pressure. Because your pressure is giving, so it can change the state. Solid carbon dioxide is stored under high pressure, and solid carbon dioxide gets converted directly into gas and on decreasing pressure to 1 atmosphere. Pressure, if you decrease, then what happens? It changes to gas without coming to liquid state. Without coming to liquid state, solid carbon dioxide changes to gas by decreasing pressure. So, solid carbon dioxide is known as dry ice. Because it looks as ice, so it is called dry ice. What is the full form of dry ice? Solid carbon dioxide. It is formed by cooling under high pressure. Remember, high pressure, it cools and gives dry ice, first turning it into a liquid, further cooled and expanded to form a snow-like structure that is called solid carbon dioxide, that is called dry ice also. So here, dry ice, how it will change. Conclusion, what is conclusion? Pressure and temperature determine the state of matter, whether it will be solid, liquid and gas. How liquefied by pressure, how it changes to solid, changes to gas. These all are depending on the temperature and pressure. Then what is the conclusion then? Interconversion of 3 states of matter. You know there are 3 states of matter: solid, liquid and gas. We will start from solid. Solid on sublimation changes to gas. Gas on deposition changes to solid. Deposition means giving a light cooling effect. Then fusion, solid change to fusion on heating. Liquid changes to solid on solidification. Condensation, gas condensed to liquid. Liquid on evaporation gives gas. See here, all the conversion of the 3 states of matter depends on the temperature and pressure. Liquid evaporation, what will give? Gas. Condensation, what will give? Liquid. Liquid solidification, what will give? Solid. And fusion gives liquid. Similarly, solid on sublimation gas, and gas on deposition come to solid. That is, then 3 are conversation of the 3 matters of matter. Before evaporation proceed, it concludes some important points. We will go to evaporation, but you know what is evaporation. You should know what are the minimum definition, minimum point, so that evaporation will be easy to understand. What is melting or fusion? The change of the state from solid to liquid is called melting or fusion. It is melted. What happens? That means the distance between the particles of the state is increasing. So it is melting. That means change of state of solid to liquid is called melting. Then what is melting point? The process is called melting. Then what is melting point? You should note the temperature. The temperature at which solid changes into liquid at the atmospheric pressure, and that is called melting point. Every everyone has melting point. Let us see melting point of ice 0 degree centigrade. So Celsius centigrade, that is 0 degree. Then what is in Kelvin? That is called 273 Kelvin. So melting point of any solid you should know by the thermometer, that whether what is the melting point of ice, what is the melting of gold, iron, silver, anything, sodium, you should observe it. Then here vaporization process क्या है? What is mean vaporization? Vaporize mean it will changes into gas. The change of state from liquid to gas, that is called vaporization. In vaporization what happened? Here it something boils. What is the boiling point? The temperature at which a liquid starts to boil. And what is the pressure? Atmospheric pressure. That means pressure is very important. Always atmospheric pressure very important. Boiling point, melting point, all the things should be at atmospheric pressure. So what is boiling point? Temperature at which a liquid starts boiling at atmospheric pressure is called boiling point. Then what is vapors? A substance in gaseous state under ordinary condition. It exists in liquid and solid state. Vapor, when you heat a boil, or that means boil water in a beaker, you can observe some gases coming from the beaker, and that is not gas, it is called vapor. Vapor means it exists in liquid or solid state combinedly. For example, water vapors, water as liquid. Water vapors mean water as here liquid. The liquid or solid state, it is a combination state. Then bromine vapors. What is mean bromine vapors? Vapor mean here bromine, nature is liquid. What is nature? Liquid. When it comes to vapor, changes to vapor medium, then we call bromine vapors. What is sodium vapor? Sodium actually is a solid. On heating what happens? Some gas looking coming, that is called vapors. Sodium vapors. That means sodium changes to gas form. Before that it was solid. So it is called sodium vapors. What is diffusion? Diffusion means mixing, intermixing of particles of two or more substance. Two or more substances mix on their own. It will mix itself. Then it is called diffusion. Diffusion I told already in the chapter video, third video, where I told just like intense stick, the smell of the stick is going throughout the house. This is due to diffusion. And freezing. Freezing, what is freezing? Change of state from liquid to solid. Change of state means changing liquid to solid. Condensation, just like this, change of state from gas to liquid. When gas to liquid, that is called condensation. When change of state from liquid to solid, this is a process where process is going on. After that, you can note the temperature and what is the freezing point and solidification point. Here you will note the temperature. What is meant by atmospheric pressure? Pressure exerted by the atmosphere at what condition? As it is 1 atmosphere pressure, 760 mm of mercury. It is different place, you know. Some places which is level is near to sea, equivalent to sea, but some are above and below, above the sea level. So it is different and different place. At sea level, it is 1 atmosphere. Generally, what is that one? 1 atmosphere is counted, and here it is called above 1 atmosphere, above the sea level, like this. In everyday life, observe sometimes the change of state from liquid to vapor takes place without the liquid reaching the boiling point. When you heat the liquid, you can observe first it starts to boil and lastly whole the liquid boils. Okay. Now, and sometimes what happens, suppose you put a beaker of water, cup of water in outer side, after 15 days you observe liquid is going to finish, or a little amount of liquid is left behind. What is that? Before you are not heating, but at atmosphere, what is the heat required? And here it tries to change to vapor without reaching the boiling point. That is called vaporization process. And here every day we can observe in our life outside. If you put some liquid, anything, and after that of a few days it is finished totally. Water in a beaker left uncovered for some days slowly change to vapors. Example, second example, common example, wet clothes, where we are always trying to wet clothes outside. What happened? It is dried up. Then why? In both cases, water gone out to the atmosphere. These vapors go to atmosphere. In sea also, in river also, in lake also. By this process, without undergoing boiling point, only from the atmosphere the heating coming, and it gives your vapors. Vapors go to atmosphere. Then what is evaporation? The process how the liquid changes to vapors. It is a process, phenomenon, where liquid changes to vapor at any temperature, but below its boiling point. You know water boiling point what? 100 degrees centigrade, or you can say 373 Kelvin. Then what happened here? The phenomena changes to liquid to vapors at any temperature, but it should be below boiling point. This is called evaporation. It is a common process everywhere. It is going on without any man-made. You put something, and after that you find automatically dried, automatically liquid finish. What is the cause of evaporation? Evaporation is going on. That is a natural common phenomena. Nobody wants to try. Nobody doing some work for evaporation, but it is a continuous process, phenomena, that is natural phenomena. Then particles of matter are always moving. Then what is the cause behind it? We know the matter's particles here always moving without any rest. Everywhere, every place, the particles of matter are moving, but in gas it is moving with a very high fast without any rest. The particle of gas, solid, liquid have different amount of kinetic energy. All states of matter have a kinetic energy, but where it is high in gas. High in gas, because in gas the particles are away from each other, very far. That is why here kinetic energy help to move faster. At a given temperature should not be so high. At a given what is the temperature given? The kinetic energy help to move the particles very fast. In case of liquid, on the surface, small fraction of particles having high kinetic energy. Surface, because on the surface the kinetic energy is very high, they can move fastly. It is able to break the force of attraction of other particles and convert it into vapors. That means the surface area is highly evaporated due to a force of attraction of particles breaking and converted into vapors. And here factors for affecting evaporation. First effect, that is surface area. Since surface area is there and it is open to atmosphere, and what happened here, the evaporation is surface phenomenon. It is surface area increases, the rate of evaporation increases. That is why you are putting cloth in spreading way. You are taking more surface area to make dry. That is why here, remember, surface area phenomenon is most important, because here more area required for the process of evaporation. Increase of temperature, suppose in dry area, or you say summer season, that clothes, simple example, clothes dried up easily into little, so no time required for the dried up the clothes. But that one in rainy season it is very difficult to dry. Why? Because in summer season temperature is more. So with increase of temperature, then what happened? More kinetic energy is giving and changing the particles into vapor state. See, increase of temperature, increase of kinetic energy. Increase of kinetic energy, that movement of energy, vibrational energy increases, and during high vibration, it changes to vapor state easily. Decrease of humidity. What is meant by humidity? Humidity means the amount of water vapor present in air. If water vapor more, then it is humidity more, then the clothes cannot be dried up easily. Then here, at a given temperature, the air cannot hold more than a definite amount of water. Humidity means not that it contains full water molecules, that is not the one. It is mean here a definite amount of water is that it can hold. If the amount of water in area is high, then what happens? If the amount of water in area, water particles more, then called humidity high. If humidity high, rate of evaporation decreases. If rate of evaporation decreases, then the clothes you are spreading, you are keeping in outer side, it will not dry easily. Time taking. It is time taking. Increase of wind speed. When the speed of wind is more, then our clothes which are spreading outer side, that can be easily dried. With increase of in wind speed, the particles of water vapor move away easily with the wind. That means the particles of water vapor which is inside the clothes, they will go easily by the help of wind. That means so decrease water vapors on the surroundings where wind is more, then dried easily. So the clothes dried faster in a windy day. Region. What is the region? Behind the evaporation causes cooling. That means if evaporation is there, you can feel cool. Why? Question is why that evaporation causes cooling. During this process of evaporation, what happens? The particles which are present in liquid and moving here and there, they absorb energy from the surrounding. From the surrounding, it takes energy and to regain the energy lost during evaporation. You know, during evaporation, energy lost because it changes to vapors. And here what happens? The particles of the liquid absorb energy to maintain the energy lost during evaporation. During evaporation, what is the energy lost? That can be regained easily. This absorption of heat from the surrounding make cold because it absorbs energy from the surroundings. That is why one can feel cold. Example. You know, nail polish, it is acetone present. If you put nail polish cleaner and you put on that palm, you feel cold. Why cold? Because particles of acetone gain energy from our palm. One place is palm, other space is surrounding. So, from surrounding by absorption energy, nothing felt by us. But when you put acetone on our palm, it absorbs energy from the palm. That is why here the evaporator that cause palm to feel cold. Remember again, acetone what you put on the palm, this liquid, the acetone is a liquid, colorless liquid, it absorbs energy from our palm. Since it absorbs energy from our palm, or it can also absorb from surrounding also. By absorption process, we can feel cool on the palm area. Sprinkling of water on the roof or open ground. Sometimes you can observe in summer season water you are sprinkling on the roof and also playground to play. Then what happens? It helps to cool the hot surface. It helps to cool by the only latent heat of vaporization. Latent heat of vaporization, it regain that heat. When you sprinkle water on the roof, what happens here? Due to a large latent heat evaporation, that area feeling cold. That means the roof area you are putting, that means here one can feel cool. Similarly, the hotness of the playground also decreases due to large latent heat of vaporization. Then reason for wearing cotton cloths in summer. You can observe also we are wearing cotton cloths in summer. No, it is polythene, it is a synthetic cloth. We will not wear in summer, and at home also nobody allows to put the synthetic cloths in summer. And why? We perspire. Perspire means you are taking inspiration, and due to respiration process, more keeps cool to body. You are feeling cool by the cotton cloth. Why? During evaporation, the particles gain energy from the surrounding, changing to vapors. What happened? The particles gain kinetic energy, heating energy from the surrounding to change to vapor. How? The liquid changes to vapors, and heat energy is absorbed from the body, leaving body cool. Because we are sweating, so the body heat energy is absorbed from our body and leaving body cool. Cotton is a good absorber here. Water helps by in absorbing the sweat and evaporate to atmosphere easily. Remember, we are perspire, perspire means taking here absorbing the sweat and evaporate the to atmosphere easily. Why? Cotton has some porous area, because cotton has a good quality having some porous whole area, so the water helps in absorbing the sweat. Without any hole, without any porous, that means synthetic clothes, there is no porous it has no porous, no hole inside the cloth. But cotton has having good quality of porous, so that is why the absorb that sweat and evaporate to the atmosphere easily. If we will put synthetic cloth, the sweat will not go outside by evaporation process, because it has no porous clothes. So by more perspire, more keeps cool. If you cool to body, if you giving more sweat, you are feeling more cool on during the cotton clothes you put. So this is very important. Wearing of cotton clothes in summer, it is good for cooling effect. That is why if you put synthetic cloth, you feel very sweaty and very hot also. But you put cotton cloth, then you can feel cooling effect by the absorption of sweat and evaporate to the atmosphere. Water droplets, you can observe also water droplet on the side of the glass containing ice cold water. Do at home, you take ice cold water in a glass of water. Inside you put ice cold water, and observe after 5 minutes, 10 minutes, outer also droplet comes. What happened? Water vapors in air when come in contact with the cold glass of water. Cold glass of water, because cold water is inside the glass. So what happened when the outer side atmospheric air and what is the water vapor present in air and comes in contact with the glass of cool water, then loses energy and so gets converted to liquid state as water droplets. So outer side what vapors strike to the glass, that changes to as water vapors. I hope it is clear. It is very clumsy chapter. It is very difficult chapter to understand, because almost science things are present here, science concepts are present here. So I hope it is clear to you what is meant by vapors, evaporation, diffusion, okay, deposition, fusion. So try to read 2 or 3 times, to listen 2 or 3 times this chapter. It will be clear to you. And myself, B.L.DASH, ex-PGT Chemistry, Kendra Vidyalaya Sangathan. Thanks for watching my video. Try to make understand, because it is very important in higher class. Thanks to all again.